All right, let's take another example. Suppose we have t plus 5, the quantity squared, plus 6 equals 7 times t plus 5. Now, this happens to be a quadratic equation in terms of t. And we could solve it simply by multiplying it all out, combining all terms, and then we would end up with a quadratic equation in terms of t. But if you notice that 5 squared, and here we've got a t plus 5, which is not squared, then once again we might make a substitution. So let's say let w equal t plus 5. Now we'll substitute into this quadratic equation. This t plus 5 squared will then become w squared. So we'll have w squared plus 6 equals 7 times w. And there we go. Quadratic equation. Let's put it in standard form. W squared minus 7w plus 6 equals 0. And you might notice that the factoring technique sort of jumps at you in this case. We'll have two factors. They'll have the same signs. They'll both be negatives. Factors of 6, which give us a difference of 7, in this case give us a sum of 7 because the signs are the same, are 6 and 1. And so quickly we can say w minus 6 is one of the factors times w minus 1 is the other. And then we could set each of them equal to 0. In this case equals 6. W in this case, we didn't do any squaring of both sides. And so in this case, it's not mandatory that you check your solutions. It's always a good idea to check the solutions, but it's not mandatory because we didn't do anything that would introduce extraneous solutions. But of course, there's always the idea that we might have made a mistake along the way. So if you have time, it's a good idea to check. We have to go back and use the substitution we had, which was w equals t plus 5, in order to solve for w. I'm sorry, to solve for t. We have the solutions for w here. We now want to solve for t. So if w is equal to 6, then 6 equals t plus 5. In solving for t, we get 6 minus 5, which is 1. One solution is t equals 1. We'll have, in this little substitution equation we used, 1 equals t plus 5. It turns out then that t is equal to a -4. And as I said, if you have time, check your work so that if you made mistakes along the way, you'd find them. But in this case, it's not mandatory to check. Okay? All right, let's do another example. We've seen two different kinds of equations that we can make into quadratic equations. Let's consider something that doesn't look be working with some powers. Let's say 3x to the 2/3 power minus x to the 1/3 power minus 24 equals 0. Well, you might notice that if I because if I have x to the 1/3 and I square this, remember with properties of exponents, we have a base to a power, we would becomes x to the 2 times 1/3, but that's nothing but x to the 2/3. A substitution to have this equation. Let's do a y substitution, maybe. So let's let y equal to x to the 1/3. And as we've seen, if we square the y, that would be squaring the x to the 1/3, we end up with x to the 2/3. So here we go. This is one of the variables that we have here, x to the 1/3. X to the 2/3 is the other variable that we have here. Not the other variable, but the other form of the variable. So let's substitute x to the 2/3 instead. For that, we're going to have 3y squared minus x to the 1/3, which would be a y, minus 24 equals 0. Okay? All right. So Once again, we can use the techniques for solving quadratic equations. This particular equation is going to factor, but it might take a while to try to find the factor, so maybe we could use the quadratic formula. So let's say A equals 3, B equals -1, and C equals -24. By substituting this into the quadratic formula, remember, minus B plus or minus the square root of B y, not for x. Eventually we have to do that, but in this case, we're using the quadratic equation that we were able to transform the original equation into, and so we'll solve that equation for y. So the solutions for y are given minus a -1 plus or minus the square root of -1 squared. And again, I remind you, put that negative value of b in parentheses and then the square on the outside so you don't get confused. Minus 4 times a times c divided by 2 times a. Okay? So what are we going to have? Y equals 1 plus or minus the square root of 1. And here we have a minus times a minus, which would be a plus. We're going to have 12 Now, I don't have my calculator here, but 12 times 24, we can multiply that thinking that that is the same thing as 12 times 12 times 2, right? But 12 times 12 is 288. So now we can say y equals 1 plus or minus the square root of 1 plus 288 divided by 6, and then again, for this, you might want to use your calculator to see what the square root of 289 is. I just happened to be working with it the other day, and I remember that it is the square root of 289 is 17. So y equals 1 plus or minus 17 divided by 6. So what is that? Either y is 1 plus 17 divided by 6, or y is 1 minus. Right? So we'll have y equals 18 divided by 6, or y equals a negative 16 divided by 6. Or y equals a negative 8/3. Okay? But those are solutions for y. What we were interested in solutions for the equation minus x to the 1/3 minus 24 equals 0. We were interested in finding solutions equal x to the 1/3. So now we have to go back and find the solutions for x. Okay? Well, how do we do it? Since we know that y is equal to 3, we're going to say 3 equals x to the 1/3. That was one of our solutions. We want to retrieve the x. Well, what we can do is we can cube both sides, right? So we'll cube the left-hand side, and we'll cube. You're taking an equation, both sides of the equation to a power, it's a good idea to check. So we'll have 27 equals x. So one of the potential solutions is x equals 27. And I will call these potential solutions. The other equation, when we have y equals a negative 8/3, if y is equal to a negative 8/3, then y a negative 8/3 equals x to the 1/3. And once again, both sides so that we can get to the x. So we'll have negative 8. right-hand side, we end up with x. On the left-hand side, we're going to end up with the negative 8 cubed is minus 512 divided by 27. Okay, that's another potential solution. So we've got two potential solutions to look at, this one and this one. So let's do the check. Equation, which was 3x to the 2/3 minus x to the 1/3 minus 24 equals 0. Okay? So if we put 27 for x and take that to the 2/3 power minus 27 to the 1/3 power minus 24, is this going to be equal to 0? That's what we want to know, right? But remember that when we take a number to a rational exponent, the denominator of the exponent tells us. And so here we've got 3 times the cubic root of 27, and that needs to be squared for this first term right here. Well, the cubic root of 27 is 3, so we have 3 times 3 squared. That's 9 times 3. We end up with a 27 for the first term. Okay? For the second term, we're simply going to have this is going to be a 3. So 27 minus 3 minus 24, is this equal to 0? Sure. We have 0 on the left, 27 minus 27, 0 on the right. So it turns out that let's check the other solution. It is not. So the other solution, the other potential solution, is x equals a negative 512 over 27. So let's once again look at the equation we were working with, which is 3 times x to the 2/3 power minus x to the 1/3 minus 24 equals 0. So we'll substitute in the negative 512 divided by 27, take that to the 2/3 power, minus a negative 512 over 27 to the 1/3 power, then subtract negative 24 and see if this is equal to 0. Well, if you remember, we got the negative 512 by is just 3 times the cubic root of negative 512 27ths squared, right? The thirds means the cubic root, and we're still squaring that number. Well, this, as I reminded you, is negative 8/3. If we square this and multiply by 3, what are we going to have? Well, we'll have 64/9 when we multiply by 3. Finally, we end up with 64/3, right? 3 goes into 9 3 times, so we'll have 64/3. Okay? How about for sevenths? But the cubic root of a negative is negative, so we're going to have 512 was 8 cubed, right? We still have this 24 that we have as the third term. All right, so finally this is just simply a plus 8/3. And so now let's see if 64/3 plus, if this is equal to 0. Well, as you can see, 64 plus 8 is just 72 over 3. 72 over 3 is 24. Minus 24 equals 0. So the second solution checks also. So the solutions in this case, after transforming this equation into a quadratic equation, are x equals 27 or x equals a negative 512 over 27. Okay? So once again, by doing some substitutions, we may be able to take an equation such as this one, 3x to the 2/3 minus x to the 1/3, which would be pretty hard to solve if we didn't make that substitution. We make a substitution, we transform it into a quadratic equation, work that out, then get potential solutions, check them out, and that way we're able to solve some equations which we wouldn't be able to solve directly, as in this case.